Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Into Chaos by Yitrio, and here are the rules. We have chaos construction rules where each row, column, and region must contain the digits 1 through 7 once each. And this is a 7 by 7 grid, so that's how that works. Regions consist of a set of 7 orthogonally connected cells and must be determined by the solver. So as an example, what is an orthogonally connected region? It means you can go from any cell in that region to any other cell in the region just by going through edges while staying within the region. So this is an example of a valid orthogonally connected region, because to get from here to here, you can just go through these edges while staying within the region. What is an example of an invalid orthogonally connected region would be something like this, because these two cells cannot connect to these cells just by going through edges while staying within the region. Even though they can connect to each other by doing so, they can't get to these cells here unless they go through a corner or they go through an edge and exit the region. So that's an example of how orthogonally connected regions work. We also have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. And no 2x2 area is fully shaded or fully unshaded. So the same thing that applies for orthogonally connected regions also applies to orthogonally connected shading, right? So for example, this must be able to connect orthogonally to this digit here, and it can by just going through edges while staying within the unshaded region. Same with this. To get from here to here, you can just go through these edges here while staying within the shaded cells. So and an example of an invalid shading would be something like this, because for yin yang, because this 2x2 area is all fully shaded, and that's not allowed. Every region is either fully shaded or fully unshaded. So if you have if you have an orthogonally connected region, it can only be all shaded or all unshaded. So you could not have a region, say, do something funky like this or something, because then that would be partially in the shaded and partially in the unshaded regions, and that's not allowed. Digits separated by a white dot are consecutive. Additionally, they are in separate regions, but have the same shading. So these would have to have the same shading, but are in different regions. So for example, if this were, say, a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. Digits separated by a black dot have a ratio of 2 to 1, and additionally, they are also in separate regions, but have different shadings. So if, for example, this were shaded here, this would have to be unshaded here for that to work. And if this were, say, 6, then this would have to be 3, because they have to be in a 1 to 2 ratio, because they have a black dot between them. Not all possible white and black dots are necessarily given. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so these have to be different regions for... I guess we should make it black. These are different regions for all of these cells. And they are also different shadings. So this is a different region, but these are the same shading. The only digit from 1 through 7, which is in a 1 to 2 ratio with 2 unique digits, has to be 2. Right? Because if it's not 2, well, it just doesn't work. 2 is in a 1 to 2 ratio with 1 and 4. Normally, in normal Sudoku, you could also have 4 be in a 1 to 2 ratio with 2 unique digits, but that requires an 8, which we don't have here in the 1 through 7. So this must be 2 here. This is 1 and 4 in a 1 to 2 ratio. That means the remaining digits in this row have to be 3, 5, 6, and 7. Well, the only digits 5 and 7 can never be in a 1 to 2 ratio, even in this 1 through 7 Sudoku. Because again, if you have 5 or 7, you get 2.5 and 3.5. If you double 5 or 7, you get 10 and 14. So this has to be a 3, 6 pair to be in a 1 to 2 ratio. The rest of this is 3, 5, 6, or 7. Okay. If this were 6, the problem with that is this digit would have to be 5 or 7, which is not going to be in a 1 to 2 ratio with another digit. So this cannot be 6. It's 3, 5, or 7 here, which forces this to be 2, 4, or 6 here. Regions. So this is going to have to be a different region than this. So this we're going to mark as dark. And these are different shadings. These are same shadings. So we know this has to go that way. This has to go up. These are same shadings also. So the only digits which can be in a 1 to 2 ratio with each other, again, can be 1, 2, 3, 4, and 6. This cannot be 3 and 6 in the rest of column 1 because of the 3, 6 pair. So we have 1, 2, 4, 5, and 7 available. Okay. These are all the same shading because this is the same region here. Hmm. So since these are all the same shading, this must be different shading. Okay, let's just do shading right now. So this is the same shading. This has to go out as a region. This is a different shading. So this must be green, which makes this blue, which makes that green for the different shading. This has to orthogonally connect out, so this is blue. And it's a 7-cell region. We have 1, 2, 3, 4, 5, 6, 7 potentially. Green has to orthogonally connect out to the rest of the greens. Um, um, so this is guaranteed to be in the same region as this because we don't have any other way to go. So then this cannot be a 2. We have 4 and 6 here. If this is 4, this is 2. If this is 6, this is 3. What else do we have? These are the same shading. These three must be the same shading, so this has to be a different shading. So we'll mark that as red and we'll mark that as pink. This must go through another region. This has to go orthogonally to fulfill as a region, so these are all red. We have a change of shading here. So you can, on the edge of a grid for yin-yang shading, you can only change shadings twice or 0 times. And the reasoning is just the how it works. To connect orthogonally, you can't orthogonally connect unless you can only change shadings twice. So this is a change of shadings, this is a change of shadings. Those are the only changes of shadings we have. Therefore, all of these are the same. Actually, let's make the blues green. We're going to make it something different, and then these will be blue. Therefore, this is green shaded. So that means all of these up to here must be the same shading. Then we change here, so that's green all the way here. This must be blue going that way. So this must form one full region here. Because these are all the same shadings and they can't exit out without forming a full 7-cell region here. So that's one region. We have a 2x2 area that's all blue. Therefore this is green, this is green, this is green, and this is green for that reasoning. This is then boundary here. So we have 1, 2, 3, 4 here. This is region. This is region. What else do we have? So we have those 4 are part of the same region. We have to have 7 here. So 2 cannot be here. We know one of these is guaranteed to be a 2. And this digit must be one of these digits here because we don't have it available in this box here. So this is 2, 3, or 6 here. We don't know which one of these that's there. Okay. We don't know if this is the same region or not. Both of these cannot be green because then that would have a 2x2 area that's all green. So one of these is green, one of these is blue. The green has to orthogonally connect out as a region. So that's why one of those is green. And one of those is blue. This could be, however, both greens. We're guaranteed one green here. We just don't know if it's 1 or 2. This green as a region has to exit out. This is opposite, so this is blue. Green has to orthogonally connect. So this is region. This is consecutive with that. So we have 1, 2, 3, 4, 5, 6 available. 7 is not available there. This could be all the same region. We don't know though. What else do we have? Um, how many blue cells do we have? We have one. 1 plus 7 is 8, plus 6 is 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we have to have at least 4 blue regions. We have 7 here, 8 and 1, 2, 3, 4, 5, 6, 7, but there's no way they connect. So we have to have 3 green regions here. So we need 4 blue and 3 green regions. Okay. Um. 1, 2, 3, 4, 5, 6, 7. So there's no way that these are part of the same region as this. Which means necessarily these must be part of the same region as that. Okay. Hmm. um, so far, this is the same. These 4 have to be the same region. You cannot go blue here and then go make that blue because then this would be a 2 by 2 that's all blue. So this has to be part of that region also. But we don't have any guarantees other than that. Mm. We have 1, 2, 3, 4. 1, 2, 3, 4. 5, potentially. You cannot go here because that would block green from connecting as a region to another region that is green. So blue can go at most up to here. So 1, 2, 3, 4, 5, 6, 7. So all of this right now is the same region. So it could be 1, 2 here. It could be 1, 2 here. We don't know. Oh, this can't be. If this were part of a separate region, the problem is it would have to orthogonally connect out to that region. And then that would block these greens from being part of the same region. So this must be part of this region here. So we either have 6 going there, or we have 7 as a region here. We can't have, okay, so we can't have this as a region. 1, 2, 3, 4, 5, 6, 7, because then this is blocked from having a region at all. So this has to be a separate region. That means we have to go blue there. That's done as a region for this lower left-hand corner. That means this must go blue there to orthogonally connect. Green has to get out and orthogonally connect as a region there. So then that's done as a region. Blue still has to go out. We have 1, 2, 3, 4, 5. So this is blue. Green, and then blue. This blue cannot go out because this region's still not done. Blue has to go here, and that's done as a region. Okay, so this is blue. That means green has to orthogonally go out this way. 1, 2, 3, 4, 5, 6. One of these is green, one of these is blue. So this is done as a region. 1, 2, 3, 4, 5, 6, 7. That means this must orthogonally connect as a region, so that's blue, and then that's done. So then these are the regions. Okay. We have 1, 4 as a pair here, which eliminates 1 and 4 in the rest of the region. We are guaranteed this cannot have 1 or 4. So we have to have 2, 3, 5, 6, or 7 there. That leaves this as a 1, 4 pair. We are then guaranteed 2, 3, 5, 2, 5, 6, 2, 5, and 7 are guaranteed to be here because they can't be here. So this can't be 2, it must be 3 or 6, which makes this a 3, 6 pair here. We have a 2 here guaranteed. That eliminates 2 in the rest of the region. So this can't be 1 here. Okay. One of these is a 3 or 6. We're not sure which. The other one is a 1, 4, 5, or 7. Remaining digits in row 4 are 1, 2, 4, 5, and 7. No 2 here because of 2 in the column. No 2 here because we're guaranteed a 2 here in row 1. Okay. We are guaranteed a 2 here because this can't be 2. So that eliminates 2 in the rest of the region. So it's 1, 3, 4, 5, 6, 7 there. So this can't be 1 because that would force that to be 2 there. 2 can't be here because of 2 in the column. We are guaranteed this is 1, 3, 4, 6, 5, 7. So this digit is the same as that one. So let's mark those. So that, let's mark this as A and B. Therefore, this has to be the same as that. So, because it can't be here, whatever this digit is in this region has to be here. So that's B, this is A. So that means this can't be A or B, so no 3, 6 there. A cannot be any of these digits because we have A here. This can't be B either because of B in the column. So 3 and 6 cannot be here. Therefore, this is 4, which is in a 1 to 2 ratio with 2. So no 2 there. This can't be 2. So this can't be a 2 with 1 and 4 as a ratio. So this must be a 3, 6 pair, which eliminates 3 and 6 in the rest of the row. Well, 2 can't be here. And this can't be 3, 6 as a pair because this can no longer be 3 or 6. So 2 has to be here with this being 1 or 4. We need another 3, 6 in this region, so this must be 3 or 6. And is the A 3 or 6? This can't be A or B 3 or 6, so there's no 3 or 6 there. There's no 2 here because of 2 in the column. Therefore, this can't be 2 here. No 2 there either, no 2 there. So these are consecutive. 1 can't be here because of that. That would not be consecutive. We need another 3, 6 in this region. And it cannot be here because of the 3, 6 pair in the row. Can't be here because of the 3, 6 pair in the row. So this must be the other 3, 6. And is B. That eliminates 3, 6 of the rest of the column. So this has to be A as 3, 6, and this must be B here, which makes that A. 4 is consecutive with 3 or 5 there. This is seen by both A and B, so this cannot be 3 or 6, so that's 5. That eliminates 5 in the rest of the box and row. This has a 3, 6 pair here, which means this can't be 3 or 6, it's 7. Therefore, this can't be 7, this is 3 or 6, and is the B. Okay. Seven eliminates 7 from here. Where's the 2 in column 7? It has to be here. 5 eliminates 5 here. This is 1 or 4. This 1 or 4 cannot appear in the rest of this region. So where is it in column 1? It has to be here. So we'll mark this as C. That must be that one. So this is C, which means this can't be C. That's D, which makes that C there. Interesting. So this can't be C or D because it's C is both. This 1, 4 pair eliminates 1 and 4 in the rest of the column. So no 1, 4 there. No 1, 4 there. It's 5 or 7. This is 3, 5, or 6. 2 eliminates 2 in the rest of this row. So it's either 3, 4, 4, 5, 5, 6, or 6, 7 here. We don't know which. Remaining digits of column 4 cannot be 3 and 6. This can't be 2. This can't be 2. Where's the 2? It has to be here. That eliminates 2 here. The remaining digits must be 1, 4, 5, and 7. 4 eliminates 4 here. So the C's are all 1. That means D has to be 4. That eliminates 1 in the rest of the region and row and column. That has to be 1, 4, 5, 7 there. Remaining digits in row 5. 2, 4, 5, 7. No 5 in either of these because of 5 in the region. No 2 here because of 2 in the column. This is 1, 4, 7 as a triplet, which eliminates 1, 4, 7 in the rest of the region. So this can't be 4, 7, it's 2. That leaves this as a 5 there. So this can't be 5 here. No 5 here. So this is either 3, 4, or 6, 7 here. This digit must be the same as that one. So we'll mark that as Z. 1 and 4 here. No 2 here. This can't be 7, so this is 1, 4, 5. 2 eliminates 2 here. We have a 4, 5, 7 triplet in column 1, which eliminates 4, 5, and 7 in the rest of the column. So this is 2. That is 7 2s. This 4, 7 pair eliminates 4 and 7 from here. Where is the 1 in this region here? It's guaranteed to be one of these 2 digits, which eliminates 1 in the rest of the column. So this can't be 1. Where is the 1 then in this region here? It must be here. 4 eliminates 4 here, so Z has to be 7. So this is 7, which means it's consecutive with 6. 7 eliminates 7 here, so it's 4. That leaves this as a 3. So then A has to be a 6. So all the A's are 6s, all the B's are 3s. This can't be 7 because of 7 in the box. So this is 4, 5 as a pair. This 4, 5 pair eliminates 4 and 5 in the rest of the row. So this can't be 4, it's 7. No 7 here. 7 eliminates 7 here. We have a 4, 5 pair here, which eliminates 4, 5 in the rest of the row. So this can't be 4, 5, it's 1. So no 1 here, no 3 or 4 here. Actually, all of these cannot be 4. So these can't be 6 either. We have a 5-7 pair here, which eliminates 5 and 7 in the rest of the box. So this can't be 5 or 7. It's 3 or region. No 3 or 6 here. We have 5-7 as a pair here, which eliminates 5 and 7 in the rest of the column. So that's 4, which makes this 5, which makes that 7. 7 eliminates 7 here, so it's 5 and 7. This can't be 3 or 7, it's 6. 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 4 and 5. 5 eliminates 5 here, so that's 4, which makes this 1 and 4. This can't be 1 or 4, it's 5, and 4 eliminates 4 there, so it's a 1. Yep, not too bad, but that's because it's a 7x7 Sudoku, right? So, yeah, the chaos constructions, which are smaller, tend to be a little bit easier to, because you don't have as many variables to handle. Yeah, overall, pretty interesting puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.